Topic 7-5, Simplifying Radical Expressions. This can be referenced with our whole textbook, Chapter 11, Section 6, starting on page 805. Alright, we're still dealing with, we're going to look for patterns. We're still dealing with radicals. And when you have a radical expression, you're wanting to simplify, you're wanting to find its perfect squares. So in these, there are no numbers in these first few. You're just dealing with variables. But you just want to look for a pattern. If I have two A's, I can split them up into a pair. Because remember, when we can circle a pair, they're factored outside of this radical as that pair. So that's just A. Notice that this is an even number. With an odd number, you're going to find a pair, but then there will be one left over. So there's three A's, there's a pair of A's here, and then we were using a box technique for what's going to be left underneath the radical. And I don't need the calculator just quite yet. So this one's going to be an A on the outside, but we were left with an A on the inside. Okay, so let's look at these two. Again, we have an even number. So I have to go back to my memory of when you have the same bases, the variables are the same, these are called the base numbers, and your exponents will be added together. So you think of the even number divided into two equal parts. Well, 4 is 2 and 2, so my pair is a pair of A squares. It's an odd number, so I know I'm going to have a pair, but I'm also going to have an odd man out here. And think of odd number as the odd man out. You'll have a pair of 2's because A to the 2 and A to the 2 is A to the 4, and A to the 4 and another 1 is an A to the 5. So again, your A squared goes to the outside of the radical, and you're left with an A on the inside. Alright, look at this one. Back to, notice how all these are even numbers and what's happening, and all these are odd numbers. Look what's happening. A to the 6 is a pair of A to the 3's, so that your answer is A to the 3. A to the 7 has a pair of 3's, that would get me to 6, but we have an odd man out, so A to the 3 square roots of A would be this simplified. Okay, so the pattern here was when you had an even number of powers, it's a perfect square. You see no radical sign on your square roots that have an even number power. But the odd powers, you always have one remaining on the inside. One variable remains. So knowing that pattern that's taken place, let's look at some that have a little bit bigger numbers to them. A to the 24 would be a pair of, if you get in the habit of circling pairs, it's the circled pair that becomes your answer. A circled pair of two A20's, or the pair that gets to A to the 40th. 60 and 60 give you 120, so a pair of A to the 60's would be that one. Alright, maybe pause this a minute and try to answer these on your own and then check these. But a pair of 15's goes to the outside, but this is an odd number, so there's an odd number out. You'll have an A left over. A pair of A23's would get me to 46, then you have 47 with one left over. So just be thinking odd exponents have an odd man out. Divide it in half, and then there'd be one left over. So 100 would be two 50's, but 101 has another one left over. Okay, so all of these were just variables. Now we're going to kind of mix it up and do a little bit of both. It's going to have both on it. Let's do a little bit at a time. Okay, 144 is a perfect square of 12's, and an even power has two y's. So that actually just becomes 12y. We had nothing left over. This one, if you'll just break it up individually, your whole number, your variables that are separated, If they're even numbers, you're going to have a grouping of equals. 2 2s make 4, 2 3s make 6, 2 5s make 10, and 2 9s make 81. So this actually is a perfect square root 2. 9a squared, b to the 3, c to the 5. Completely factored out of your radical. Alright, I've broken these down for you. So take a minute and try this on your own, but you're going to circle your pairs. I didn't factor this down to a 2 and a 3 because there won't be a pair for it. 6 is actually an irrational radical. You're not going to go any further with being able to factor it. 2 pairs, and x2 is x to the 4 with 1 left over to make 5. So notice, look closely at what's being factored outside. 2x squared were circled. The ones that were boxed stay under, so that would be the 6 and the x. We've got a pair of 5s over here. 3 stays outside. Underneath. You've got a pair of x's. Another, oops, those are supposed to be y's. You've got a pair of y's, but also an odd man out. So stays under is a 3 and an x. What factors out will be a 5, an x, and a y. Okay. Now we're getting to some ones that add quite a bit of factor trees here, but I've already wrote them out for you. Just go work through these slowly. You've got a pair of 9s. The 2 doesn't have a pair. You have a pair of 3s to make 6. Oops, left him. But A doesn't have a pair, so we're going to put a box around him. And then you've got 2 C's to make 4 and 1 C to make 5. Look at everything that's boxed. Everything that's in the box stays under the radical. A 2, an A, and a C. Everything that's paired up goes to the outside. 9, B to the 3, C to the 2. Alright, this is actually a perfect square. Your answer is, I'm going to put it down here, 11, because that's a pair. You've got a pair of m squares. A pair of n 2s will get you into the 4. And there's one. Oh, I'm sorry, n is into the 5, so here's your odd man out. You have a pair of P3s. If you want to spread these a little further apart than I did, it might be helpful. Into the 2, P to the 3. So I have all 3 variables have pieces of them factored completely outside the radical. But there were a couple of them that had to stay inside because they were odd numbers. So you have an N because of an odd number, and you have a P because of an odd number. So that's your answer. Last one. Oh, we're actually not finished with this one. I forgot. Don't forget this. You have to actually multiply the 3 by the 11, so your answer really is 33. M squared, N squared, P to the 3, square roots of N, P. There's your box, the answer. Alright. This just refers to the assignment page that goes with it, that check mark. Alright, I've broken it down. 9 times 8 is 72. 3 times 3 is 9. There's a pair. 2 times 4 is 8. That 2 doesn't have a pair, but 2 and 2 is 4. You have a pair of x's to make 4 and 1 more to make 5. And a pair of y's to make y to the 4. You got to remember, you got a negative 5 out here, so the negative 5 will be multiplied by, it looks like it's multiplied by a 6, because you got a pair of 3's and a pair of 2's. And you have a pair of x's, and you have a pair of y's, and what's left over is that 2, don't forget it right here, and an x. So finishing this out gives you a negative 30, and multiply the whole numbers, x to the 2, y to the 2, square roots of 2x. And that concludes 7-5.